can see this will going to be learn the futures automatically without any evidence or without any kind of the information you want to be give. But in the classical ML, you had to do so many things, right? Around to construct some of the hyperparameter tuning along with some of the, you can say, regularization mechanisms and converting from the string to integer. So many things we have done, but deep learning is a mechanisms to try to handle all the situations whenever you have some of the data to learn futures automatically. That's how the more popular, and also it's very elegant to construct any kind of the mechanisms in terms of LSTM layer and CNN and also the RNN. So most probably we have to use, yeah, so most probably we have to use CNN for some of the image classification tasks. You can say image related tasks. And for the RNN and LSTM and GRU, most probably we can use as a NLP related task. NLP related task. So the widely used mechanisms are these, and we have so many other models with constructed the deep learning mechanisms, that is the BERT model and also the bidirectional LSTM models, attention mechanisms model. So we can also discuss if possible in the miscellaneous concepts, but let's try to understand what exactly the activation function does. So whenever you give some of the input results, whenever you give some of the input data points, it's going to be try to find, and it's going to be try to compute something called as a weights. So these weights try to pass to your activation function. So activation functions are so many. I will also explain and what are the different activation functions we have. Suppose you have a neuron here, or you have a node here. So whenever you see some cat, it's try to fire to the other neuron, right? So like that, we are going to be construct with respect to whatever the hidden nodes we had. This is a very simple neural networks, I can say. If you have a multiple neural networks, and also we can also discuss MLP, multiple layer perceptron. So this perceptron having more number of whatever the activation functions we are using, it consists of the so many activation functions, that is called as a hidden layers at the time. So the hidden layers are so many. If you have more number of the hidden layers, we can call it as complex of neural network. Complex of neural network. So this type of the complex of neural network we can also call it as deep neural networks. That's why we can call it as a deep learning of the neurons, or learning of the neural network, which consists of some of the activation units we are going to be retrieved to get some of the patterns according to the functions you are just built on top of it. So if you just try to understand what exactly the activation function does, and also the weights is going to be updated with corresponding to the each and every data points we had, then it's going to be produced as a result, the output results, whatever it is going to be classification task, or it's going to be a regression task, whatever you want, it's going to be give there at the end. So if you take this consideration for the multi-layer perceptron, or the more number of the hidden units, you can say. So if you take this diagram, if you take this diagram, you can try to understand we have so many hidden layers here when compared to that single neural network. When compared to that single neural network, so this one we can also call as a multiple neural networks. We can short formally call it as MLP. MLP nothing but multiple layer perceptron. So okay, so let's try to understand what exactly it does. So you can see for each and every node we just connected to other node. You can see it is connected to the other node, it is connected to this node, it is connected to this node. This is very widely, you can say, we cannot identify which node it's connected to. So that's why it is very deep to understand, very deep to understand. So in this situation, what will happen if you try to construct, or if you try to understand which node it's going to be probability to get which node? So at that time, you cannot get that much of integrity of the details. So that's why we have some disadvantage in the deep learning called interpretability. Interpretability. Interpretability we cannot showcase to the end user. But as we invented as a classical ML, what we just learn with respect to decision tree, let's take. In the decision tree, what you have learned, you have constructed if else concept with respect to whatever the root node you had, and just splitting by using the conditions, right? So this is somewhat interpretability. Like you have to showcase this is going to be works out, if not this is going to be works out, if not this is going to be works out. So like that is going to be tell some ideas about how does your model going to be works out internally. But if you showcase these diagrams, you cannot be learned that much of integrity of the feature interpretability of the systems, future interpretability of the systems. So in this case, we are going to be do so many hacks to get some of the future interpretability of the models, but may not be always good practice to go about the deep learning concepts to get the interpretability. If you want interpretability of the models to the end user to showcase, you can always go with the classical ML. This is one of the better approaches when compared to the deep learning mechanisms what we are learning. So it tried to identify the patterns automatically. That is a major reason, and also computation efficiency is very high when compared to the classical ML what we had. If we go to next diagram, if you take a look on the back propagation algorithm, so this is one of the best algorithm in the overall neural networks, and we are going to be learn this all the time whenever you learn any concepts like LSTMs, GRU, and something called as RNN, CNN. So every time you have to learn back propagation algorithm. And how does it going to be work? So let's check out that. So I hope you already learned something called as a chain rule mechanisms in 11th and 12th grade. Chain rule. So if suppose I will derivative with respect to dl by dx, can I write if suppose dx1, let's take, so can I write dx2 multiplied by dx2 by dx1? Because this is going to be cancelled, I will get this one only, right? So can I write dl by dx3 is equal to dl by dx2 multiplied by dx2 by dx1 and dx1 by dx3? Can I write like this? I always write it like this, right? So it's going to be cancelled together. You can say it's going to be cancelled together, it's going to be cancelled together. You will remind get these values only, right? So this is a chain rule. Whenever you encounter, why I'm writing this, I will tell you. Why I'm writing this, I will tell you. But as per understanding chain rule, this is a chain rule. The concept of the chain rule is this: whenever you write any kind of the equation, you can also write without construction, without identifying with respect to the other nodes. So why I'm writing this? If suppose I have a other nodes, or I have a other hidden nodes. So let's take this is one hidden node, and this is one hidden node. This is one hidden node. So I will just construct it with respect to the different hidden nodes and try to applying this concept into our neural network model. So this is going to be helpful in the back propagation algorithm and something called as memoization. So what exactly the memoization does? Memoization is a concept when we are going to be learn something. If suppose I learn some node, it will learn first and reuse it multiple times. Reuse it multiple times. Learn something and learn once. You can say learn once and reuse it in multiple times. So that is nothing but a memoization. We going to be apply some concept or theoretical concept with respect to the neural network. So back propagation algorithm works with respect to the addition of chain rule plus memoization. Chain rule plus memoization. So whenever you learn chain rule plus memoization, that's how it's going to be works out. If you take this diagram, let me try to explain you how does that going to be helpful. So first step for the back propagation algorithm, you need to initialize the weights. Initialize the weights. So you can see here, you can see here, these are the independent nodes what we had: x1, x2, x3, x4. x2, x3. So what will happen with respect to initializing some of the weights? So I have initialized the weight 1. Let's take weight 1, weight 2, weight 3, corresponding to the each and every data point what we had. And the second step, what will happen? Yeah, you can say in this also, we will also construct some of the weights, right? Yeah, you will also construct some of the weights. So in the second step, what will happen for each xi in D, for each xi in D, I will pass forward through network, forward through network. For each and xi, I will pass forward through the network and it will compute some of the loss results. You can see this is a W1 and this is W2, this is W3. I will pass each and every node corresponding to whatever the weights we have initialized. So initialization of the weights is also another concept. We have so many multiple initializations we had. So this is also one other good concept to learn how to initialize the weights. So we have so many other different mechanisms like he initialization, tan H initialization, and something called as Xloret initialization. So we can also learn this little bit later, but as of now, you can say this is somewhat the initialization mechanisms to implement the weights what we had corresponding to the each and every data point. So I will pass each and every xi in the D through the forward direction. You can say this is somewhat the forward direction, right? When compared to, so whatever the independent, this is the input layer, and this is the some of the hidden layers you had. Okay, this is the hidden layers, and this is the output you're going to be get at the end by hat.